Alright, so today we're looking at exponent rules. So some of this stuff is kind of review for you, hopefully. It's stuff that you've seen before, that you've used before, even if maybe you didn't really realize it. And some of it's going to be completely new stuff. So I guarantee the stuff we do today that you will have at least one question about this, like on the ACT. I guarantee that once we start doing some of these examples, you'll be like, hey, this reminds me of a problem from last. So stuff here and there throughout the rest of your math school or college if you're going to college. So properties or rules we're going to talk about. First one is the multiplication property. So don't freak out, but there's about to be several letters in here. So say we've got A just represents a number, and it's raised to the power of M. And that's going to be multiplied by number A raised to the power of N. So those are just two numbers that are raised to an exponent. If you multiply those together, your answer is going to be A to the M plus N. So your number, your A, so if we look at this example, we've got 3 squared times 3 cubed. So 3, that's like our base, that's our A. So it stays, and we've got an exponent of 2 and an exponent of 3. We just add those together. So 2 plus 3 gives us 5. So 3 to the 5th. That's all we do.
How do you multiply the 3?
Those are our bases. So like, just hold that thought for a second. I think it'll make more sense once we do the next two. So let's look at these. Here our base is X. So X is like our A. And then our exponent is a 4 and a 7. So 4 plus 7, 11. X to the 11th. This might answer your question, JC. Really, whenever we do an exponent, like 3 squared, all that is 3 times 3, right?
Yeah.
So that's 3 squared, and we're multiplying it with 3 cubed, right? So that's just 3 times 3 times 3 again. So that's like the expanded form of it, and we've got 1, multiply the 3's and get 9 to the 5th, then you can see your answer's way off. So your bases are always going to stay the same, but the exponents you add. A good question. Alright, let's look at this third example over here. So here we've got a 2 and a 4. Now when it's like this, when you have coefficients, numbers attached to variables, and you're multiplying, then you can multiply them. So we've got a 2 and a 4. 2 times 4 is, we get 8. And then we've got x's. Those are like common bases. And we also have y's. So we can kind of split this up and break it up into each individual base. So we've got our coefficients. 2 times 4 is 8. Then we've got x squared times x cubed. So we'll get x to the 2 plus 3.
So if they're different numbers, we have to multiply?
Yes, if they're like this, if they're attached to like letters, then yes. And then for our y's, we've got y to the 1 times y to the 5th. So 1 plus 5, we get y to the 6th. So that is the multiplication property. That one we will use a lot. The next one we will also use a lot. It's called the power property. So up here we were talking about multiplying two numbers that have a common base, that have exponents. For this one, we're going to talk about a number that's raised to an exponent. That's raised to an exponent. It's kind of like a double exponent. So when you have one like this, you still have your base of A, and your exponent, instead of like up above it was m plus n, now it's going to be m times n. So a power raised to a power, we multiply. A power times a power, we add. So here we've got 5. That's like our A. And it's cubed, and then it's also raised to the 4th. So we multiply 3 times 4. We get 12. And that's our answer. On the next one, our base is x. And then we've got, it's x cubed raised to the 11th power. So 3 times 11 gives us 33. Alright, now this next one's a little bit different. So just like up above, when we have these coefficients, these numbers attached to the variables, everything inside this set of parentheses is getting squared. That's what this is out here. It's outside of the parentheses, so it's squaring everything on the inside. So that includes our 4. So if we get 4 squared is 16. X to the 5th squared. So 5 times 2. We get x to the 10. Y to the 3rd squared. Y to the 3 times 2 is 6.
Where did you get the 16 at?
16 comes from, you see the 4 up here?
Yeah.
So it gets squared too. So 4 times 4, 16.
Why would we get a 6 then? Because like it's free squared.
On the y,
Yeah.
because we're multiplying. If it's y to an exponent, right here it's y to the 3rd, we multiply it by the exponent on the outside. That's the power property. If you have an exponent raised to another exponent, you just multiply them.
So the 4 in front is not an exponent. The 3 that's with the y is an exponent. There's a difference. Numbers in the front, you just square like normal. Exponents, you
So like on the z here, it's raised to the 7th power. So here we multiply the 7 and the 2, which would be 14. Alright, next we have the division property. So we've got our base of A to the n power. So we're talking about division here. What's the opposite of division? Multiplication. So up here for the multiplication property, we added our exponents, right? So if division is the opposite of multiplication and we added our exponents, what do you think we're going to do with our exponents here? We're going to subtract them because division is the opposite. So that would be equal to A to the m minus n. Another way to think about this one, and I think it's a little easier, is you can just cancel them out. So say you've got x cubed over x. That's really like you've got 3 x's on top and 1 on the bottom. So the 1 on the bottom gets canceled out and 1 on the top gets canceled out. So really you're left with 2 x's on top, so that's x squared. I think it's easier to think about it that way because sometimes if the exponent in the denominator is bigger than on the numerator and you subtract, you're going to get like a negative number. And it can get a little confusing when you do it that way. So if you just think of it as canceling each other out, I think that way is a little bit we're going to get for that one. That's good. Next we've got x to the 17 over x. We've got a 3 and a 9. So since those are attached to the variables, we can go ahead and divide those. Which 3 divided by 9, if you put that in your calculator, it's going to give you a decimal. But it's really 1/3, like when you simplify it. So we get 1/3. And then we've got 10 x's on top and 4 x's in the bottom. So how many are we going to be left with? 6. Now are those 6 going to be in the numerator or in the denominator? In the numerator. Good. Because the 4 on the bottom, they got canceled out. So we're left with just the 6 on top. Alright, the zero property. You guys are going to love this one. Last class they said they didn't remember this. Do you remember in elementary school when you did like the little rhymes to remember multiplying stuff and you learned that 0 is the hero?
I don't remember.
And you like put a cape on the 0?
I don't know. What elementary school did you go to?
I went to Mount Vernon.
I think that's the only school I ever did that.
Yeah. Well, you guys are missing out if you didn't get to learn all those. They had like cool rhymes all the way up to 12.
He said something yesterday too that I ain't never heard in my life about big ball.
Oh, the gallon man?
Yeah.
Yeah.
I remember that.
Yeah. So anyway, any number raised to the 0 power, that's just going to be equal to 1. So it doesn't matter if it's 5 to the 0 or 5 million to the 0. It's just going to be equal to 1. So what's 100 raised to the 0 power? 1. What about xy raised to the 0 power? What about 5 times a plus b raised to the 0 power? Tricked you.
B. I don't know where call
No.
it. I call it 1 too.
So the exponent 0 on this one, it's attached, it's on these parentheses, right? So everything inside those parentheses is being raised to the 0 power. But this 5 out in front is not. So really what we've got here is 5 times 1. Because this a plus b raised to the 0 power is equal to 1. So really you're going to get 5.
Like a worksheet, at least we label what kind of property they are.
No. You just got to,
Seriously, dude?
seriously.
This cheat sheet, we better have a 2-page cheat sheet.
For this unit. We got a bunch of, we got a lot to write.
Alright, so really the first 3, you've probably seen a little bit of. 0 property, maybe, maybe not. These last 2 might be completely new to you. So this next one's called the negative exponent property. So that means you can have an exponent that's like a to the negative m. And all you do if you have a negative exponent, we know that even whole numbers like 4, you can write that as 4 over 1, like as a fraction, right? If you have a to a negative m, all you do is flip it from the numerator to the denominator and make the exponent positive. So instead of a to the negative m, you get 1 over a to the m. Another thing that you might want to write down that you'll see some is if you have, say, b times a to the negative m. What's our negative m on? Is it on the a or on the b or on both of them? It's on the a only. So when you use this negative exponent property here, the b stays in the numerator and the a to the m goes to the denominator, because that negative exponent doesn't have anything to do with the b. It's just attached to the a. So let's look at this example. We've got 5 to the negative 2. So that's going to go to the denominator. Our exponent goes from a negative 2 to a positive 2. And we can even simplify that. What's 5 squared?
10.
That's 5 times 2.
Oh, 25.
25, there we go.
So we have to simplify with writing how it works.
If you had 1 over 5 squared, I mean, it'd still be right. You just got to know, like on a test, if it's multiple choice, it might be C might be 1 over 25, and if you got 1 over 5 squared and don't see 1 over 5 squared as an answer choice, you might start freaking out and guessing. So you just got to know that you can simplify it. On the next one, we've got x to the negative 6. So the x goes to the denominator, and our negative 6 turns positive. And that's all we can do on that. Alright, then we've got 16x to the negative 10 over 2y to the negative 2. So again, just like on some of these up here, we've got a 16 over 2. We can divide that. So what's 16 divided by 2? 8. And I'm going to write it as 8 over 1, just so that we can keep it as a fraction. So we've got x to the negative 10 on top. Where's it going to go? It'll go to the bottom, and the negative 10 will turn to a positive 10, and the y will go from the bottom to the top. we'll get a positive 2 exponent instead of negative. Alright, the last one here, called the rational exponent property. So this one, you can have exponents that are fractions. So a to the m over n. And that's going to equal, we're going to call it the nth root. The n just comes from the denominator. So you can have like a square root, like we did some of those last unit. You can also have like a cubed root or a fourth root. So the nth root of a, our base, and it's raised to the m power. So the m comes from our numerator. So that looks pretty wild there. Let's look at the example. So we got 36 raised to the 1/2 power. So 36, that's our base, our a. The denominator is 2, so it's going to be the square root of 36 raised to the 1 power, which is just the square root of 36. What is that? 6. The next one, our base is x. Our denominator is a 7, so it's going to be the 7th root. On the inside, we've got x raised to the 5th power. Alright, last one here. Our base, everything that's inside the parentheses there, that's our base. So 3x squared. Our denominator is 2, so it's going to be the square root of 3x squared. And our numerator is 3, so that means everything that's on the inside is going to be raised to the power of 3. So now we've got like a 2-in-1. We've used the rational exponent property, and we're also going to have to use the power property up here, because we've got to do this 3x squared raised to the 3rd power. So everything that's inside the parentheses is getting raised to the 3rd power. So 3 cubed, 3 to the 3rd power. We get 27. So that's 3 times 3 times 3. And then we've got x squared raised to the 3rd power. We do 2 times 3. So we get the square root of 27x raised to the 6th power. Alright, turn it over on the back. We're going to do some examples together. I'm going to do, so I don't just do like the 4 easier ones and then leave you all the 6 harder ones. I want to do all of the odd ones with you and then let you do the even ones. So number 1, we've got a 5x squared times negative 7x to the 6th. So we can multiply this 5 and negative 7. What will that give us? Negative 35. And then we've got an x squared and an x to the 6th. So we're multiplying those. So what do we do with our exponents? If we're multiplying, we add them. So we've got 2 and a 6. So 2 plus 6 will give us 8. So negative 35x to the 8th. Number 3, we're going to be using the which property? What's it look like? The which one? Division? Yep, we're going to be using the division property. So, let's see, what is 54 divided by 3? 18. So we're going to have 18 over 1. And the division property, what do we do with our exponents? Subtract them. So we've got x to the 6th on top, x squared on the bottom. We'll have 4x's left in the numerator. And then our y's, we've got 4 y's on top and 1 y in the bottom. That leaves us with 3. 4 minus 1 is 3. So that's our final answer there. Number 5, we've got 10x all raised to the negative 7 power. So is that negative 7 exponent, is that on the x? Is it on the 10? Is it on both of them? It's on both of them because it's all in parentheses. So which property are we using on this one? We're using the negative exponent property. So we've got this negative exponent out here. So what did we do with those? We just flip them, right? So instead of 10x, we're going to have 1 over 10x. And what happens to our exponent? It goes from negative to positive. So we've got 1 over 10x all raised to the 7th power. Alright, 7's a little trickier. Right, so we're going to have to do the negative exponent property first. So that's going to be, our negative 1 is on the 2m squared. So where's the 2m squared going to go? It's going to go to the denominator. And that's going to be multiplied with the 5 that's down there. So we've got 2m squared. That's raised to the 1 power. You don't have to leave the 1 power there. But it's multiplied with 5. What is 2m squared times 5? If we multiply the 2 and the 5, what is that? 10. And then our m squared stays. No. If you did put parentheses around it, as long as it was around the whole thing, it would still be right. But you don't. There's no need to. All right, number 9 here. This one's got a couple steps to it. So who remembers the acronym PEMDAS? Can you? What is it? So that's how you remember it. You remember what it stands for, like the math?
Parentheses, multiplication.
Right. So on this one right here, there's a couple different things we've got going on. We're multiplying these two things, the 3x to the 5th and the 5x cubed. But we've also got an exponent out here. So which one do we do first? According to Aunt Sally. Parentheses, and then exponents. So this square on the outside parentheses, that's what we're going to do first before we multiply them. So that's going to be the what? The power property. So we've got 5x cubed, and that's all squared. So what's 5 squared? 25. And when we've got a power raised to another power, what do we do with our exponents? Multiply them. So 3 times 2 gives us 6. Now we're ready to multiply with our 3x to the 5th in front.
That extra x, that x sign multiplication.
I'll put a dot. Alright, so 3 times 25. You got 3/4. How much money you got? 75. So we're multiplying now. We're using the multiplication property. We've got x to the 5th and x to the 6th. What do we do with those exponents? We add them. So 5 plus 6,
30.
we get 11.
No, wait, yeah, you're right.
5 times 6 is 30. I knew what you meant. Alright, I want you all to do start at number 2 and work your way down. You can work together in these with people around you.